So, good morning, class. So, today's session we will continue with valuation wherever we left off in the previous class. Okay.
Good morning,
So,
sir.
let's just have a quick recap of what it is that we will be talking about in today's lesson. Just a moment. So, as you see over here, we're going to be moving towards looking at key definitions, and we will be talking about the physical and economic life of buildings, because those are the next two key aspects that you have to keep in mind when we're talking about valuation. Okay. So in this unit, we're going to be looking at these as our key questions. What are the key terms related to valuation? What is depreciation? How does it feature in the valuation process? What are the methods which are used to calculate depreciation of an asset? Okay. So a small recap. In the previous class, we talked about what value is. We talked about it representing worth, utility, and attachment, and that it differs from one person to another. And it must represent physical economic weightage, emotional weightage, and must possess economic and legal qualities. Correct? Then we moved on from value to market value, which is basically the estimated amount for which an asset should exchange on the date of valuation. Again, this is basically the definition that we talked about in terms of market value. Correct? Then we looked at the 8 factors which determine market value. Then we moved on to the idea of valuation itself. So we talked about it as a process by which the value of an asset is estimated. Okay. Now, we have to start looking at some key terms which are associated with valuation. So since we are talking about it in terms of architecture and construction over here, we have to look at it purely from the idea of an asset which is a building. All right, we talk about an asset as in a building over here. So the first thing that we talk about is the plinth area. So I'm fairly certain most of you guys have encountered these questions over here, exactly what the plinth area is. So ideally, these are definitions which you guys should be familiar with, but we are recapping it over here so that you remember it when you are trying to jot down a set of answers. All right. So it is the built-up covered area measured at the floor level of any story of a building. So a plinth area can be applicable not just on the ground floor, but it also can be applied on the first floor over here. So there is this misconception that, let's say, if you have around 40% of ground coverage, only 40% can be considered as plinth area. But it does not take into consideration where you completely eliminate the ground floor in a particular structure. So let's say, for example, on the ground floor, I have full stilt parking. Where is the plinth? Correct? So in that sense, we have to consider plinth area as the built up covered area measured on each floor of the building. This is inclusive of projections which are made for the purpose of balconies, for the purpose of sit out, so on and so forth. Okay. I hope we're clear until this point. So the next key term we talk about is the floor area. Okay. So the floor area is the plinth area minus the area of the walls. So over here, we talk about it as the area which is within, it is the clear area between the wall surfaces. Okay. So we can call it as the tiled area, so on and so forth, whatever it is. Okay. And this will exclude stair areas which are provided for the staircases and the lift wells. Okay. Carpet area is the habitable area of the building at floor level. So it we generally have this confusion between what is the floor area and what is the carpet area over here. Okay. So carpet area is basically the idea that there are certain places of the building which are habitable. You know, you are sitting there, you are staying, prolonging a period of stay in those particular areas of the building. So those areas can be considered as our carpet area. And it is basically the floor area, the previous term, minus the areas for open verandas, balcony, bathrooms, kitchens, and stores. Okay. Super built up area is the idea which comes in when we're talking about flats, apartments, or multi dwelling units. Okay. So it is the plinth area of the flat, which again we talked about in the first term. It is the plinth area plus a proportionate percentage of common areas like stairs, lift well, machine room, so on and so forth. So let us take a simple example over here. If you are in a if you are in a apartment complex which has where your apartment unit is around 900 square feet, okay, and the entire area of the apartment itself is around 10,000 square feet, right? So you deduct the amount of space which is given out for the purpose of the building itself. Take into consideration those common areas where you have ducts, where you have staircases, so on and so forth, right? And you equally divide them by the number of units that are there as a part of the apartment complex. So let us say your apartment complex has around 40 units, right? So let us say around out of 10,000 square feet, let's say around um, 2,000 square feet has been given up for the purpose of the building itself. Okay. So if that be the case, the remaining 8,000 has to be divided by 40 units. Are we clear thus far?
Yes, sir.
Okay. So the next one, rateable value. It is the net annual letting value of a property, which is obtained after deducting the amount of yearly repairs from the gross income. Okay. So this may be a little confusing over here. Gross income talks about the amount of return that you're about to get from a particular property. Okay. Your income from a property is basically through rental amounts, through lease amounts. Okay. Now, once you take those two into consideration, then the amount for yearly repairs can also encompass the amount that goes into paying your property taxes, the amount that goes towards your infrastructure payments, towards your water supply and your electricity, then any amount that goes towards yearly repairs. So if there are some, let's say, if it's a building, you expect certain amount of expenses in terms of maintenance. So let's say you have to replace an MCB. Let us say you have to replace a switchboard, or let us say some equipment which is a part of the house itself. Nothing which is brought in by a tenant or a renter can be considered as a part of the uh, amount for yearly repairs. Okay. None of the equipment that you leave there as a part of the unit itself can also be considered for this. Okay. So rateable value is basically the shell of the building itself, its letting value, and you deduct yearly repairs for all of those important aspects of the entire shell. Okay, from the gross income which you would have gotten. Keep in mind that the gross income is for the previous. Let us say that you're looking at calculating the net letting value for an upcoming year, let's say for 21 to 22. So your rateable value will be based on your gross income from the previous cycle, 20 to 21. Understood?
So this has no rateable value, has no connection with the resale amounts, no?
No, it does not have any connection with the resale amount. So the next term that we have to be very careful about is obsolescence. Now, by the uh, by the nature of the word itself, I think some of you guys will already be aware of what obsolescence is. It is basically a factor included in the depreciation to cover decline in the value of assets due to invention of newer and better processes or machines. It also covers change in demand of design or art, technological or legal changes. Okay. Now, obsolescence is something which you will observe almost on a daily basis. Okay. It is something which happens around you almost at breakneck speed. Okay. The simplest example of that is probably the device that you're using to actually view this presentation right now. Okay. So there is a good number of you who are probably sitting in the comfort of your homes, probably inside on your beds itself, and viewing this presentation on your phone. All right. So that kind of a facility is, let's say, was not available at least 4 or 5 years before. Okay. That kind of a facility, that kind of a convenience was probably not available. So obsolescence is where the device from 4 or 5 years is no longer uh, valuable. It has no, it has depreciate. It has decline in value in the present scenario. Okay, so a phone or a device which would have been what do you say state of the art around 5 years ago can be considered as a paperweight right now. All right. So that is how quickly things go into obsolescence. Are we clear about this? So the next thing that we look at are the three types of obsolescence. Okay. The first one we have already talked about, technological obsolescence, where it develops new technology, optimizing efficiency in production, energy consumption, and reducing operating costs. All right. So that is very key over here. We have to talk about a reduction in operation costs. If you are going to have newer technology, which still increases your operating costs because of whatever duplication that occurs, then technological obsolescence is not entirely applicable over there. Okay. So operating costs basically it reduces your it basically is talking about anything that reduces your capital outlay for the purpose of conducting activities. Okay. So a simple example over here is that technological obsolescence, the idea of an office has been rendered pretty much obsolete. Why? Because of something which we know as co-working spaces, right? Places like WeWork, like Office, AWFIS as they call it, and Beehive, all these places can be considered as those places where you have all these technological facilities available to you. So you don't have the outlay, the operating cost for owning a property, renting it out. Okay. And you don't have to put out any money in terms of infrastructure. Okay. So you have a readily available internet, you have readily available power, so on and so forth. So that way, technological obsolescence is where we have rendered the idea of a permanent office obsolete. Understood? Okay. Functional obsolescence is when a machine already in function loses optimum capacity owing to decline in cooperation from operating counterparts. arises due to faulty design, wrong location of the industrial undertaking, or due to non-availability of spare parts. Okay. Functional obsolescence comes into play where you have, when we're talking, let's talk about machinery itself over here. Um, if I have a factory which is dependent on heavy steel machinery and I decide to locate it in a coastal region, what happens?
Rust.
Exactly. So if I have heavy steel machinery in a coastal area, I am going to be looking at increase in rust. So if there is steel machinery which is working in tandem with some other machinery which has dependency on this, then I'm going to have a decline in output because one machine is not functioning to its full capacity, right? So the idea of functional obsolescence is um, it has a it has a it has two faces to it. One is where you have faulty designs where you don't exactly come up with the right specs for machinery, and you put together a whole hash of things without actually paying attention to whether or not it functions. It has a what do you say, a symbiosis, all right. And the second one is the wrong location of industrial outtaking. Okay. Then the third one, where we go to economic obsolescence. This occurs due to shrinkage in supply of raw materials, change in legislation, change in environmental laws, so on and so forth. Economic obsolescence is one of the things that we encountered during the past lockdown, right? We went into lockdown for 45 days. It was one of the most stringent things. And economic obsolescence is basically where you completely eliminate or you or where you completely suffocate your supply lines. All right. So I'll give you a simple example here. There were a lot of restaurants which went out of business. Okay. Lot of restaurants went out of business. Why? Because we had a change in legislation which stopped restaurants from actually entertaining people on a walk-in basis. Okay. So they were reduced to sending out takeaway orders. Second one is because their shrinkage in supply, because of shrinkage in supply, where you weren't able to secure the sufficient amount of raw materials. What happened was that your functionality is completely impaired. Correct. So as a result, you do not have the uh, you don't have the necessary supply chain which is important for you to conduct your business, right? So as a result of that, you go into economic obsolescence. That is a very simple example. When we are talking about economic obsolescence itself, we start thinking in terms of industry. We talk in terms of commercial establishments, all of those places which are dependent very acutely on supply of raw materials, supply of finished goods, so on and so forth. Yeah. So this is a little not entirely related over here, but still we will consider this. An annuity is an annual periodic payment for a specified number of years towards repayment of a capital amount invested by a party. Okay. So here it's probably not going to be very easy for you to understand over here, but I will give you a reverse example over here. An annuity can be even something which can be considered as a premium. All right. So a capital amount invested by a party, let's take for example over here an insurance company. An insurance company invest, let's say, figuratively invests a capital amount on you. Let us say it is going to give you a certain amount of returns after 15 years. All right. So that it says is that I'm going to give you that as a assured amount, let's say 15 lakhs. Okay. An annuity or a payment that you end up giving to this insurance company becomes a premium to ensure that at the end of 15 years, you're going to be able to get that amount. Okay. So let's say I have a 15 lakh amount which is going to come back to me at the end of, let's say, 15 years. So the premium that I end up paying is nearly around 75,000, almost on an annual basis. So that thing can be considered as an annuity over here. I hope that makes sense, right? Capital cost is basically the total cost of construction, including land, or the original total amount invested to possess a property. Okay. If you remember from your fifth semester economics, there was something where we talked about land, labor, capital, and uh, what do you say, entrepreneurship. Okay. The four factors for production. So capital cost over here in the case of valuation will be considered as the amount that is laid out for the purpose of, let's say, procuring a property, investing in the construction of a building in it, and putting out equipment on it. Okay, so that entire thing can be considered as capital cost. Yeah, another term which is commonly used for it is capital outlay. Okay, so there are a few more terms of self study over here which we are going to leave to you as an assignment. Okay, it will be considered as a part of your consolidated assignment, which will be given at the end of this end of today's presentation. Okay, so we talk about capitalized value of property, year's purchase, FSI or FAR, which is fairly straightforward, undivided share of land, reversion, aggregate area, unbuilt area, specified area, and premium. Okay, all of these terms will have to be defined in your assignment. Sorry about that. Bad internet connection problems. Um, can you tell me where exactly we left off?
So the last slide definitions. Those.
Okay, is my presentation visible right now? Just hold on.
Second part of the last slide.
This one, sir. Hello?
Some of the
Sir,
terms
unbuilt
of
area.
for self-study.
Pardon,
Yes, sir.
sir?
This.
Some of the terms for
This,
self-study.
yeah, okay. So, coming back to this, so terms of self-study, you have 9 terms over here. So you have capitalized value of property, years purchase, FSI, so on and so forth. So these 9 terms will be taken up as a part of your self-study aspect. Okay. And the self-study will be a set of definitions that you will write out for these terms as a part of an assignment which will be given to you at the end of this presentation. Okay. So let's move on. We talk about depreciation as the next key aspect that we look at. Okay. So we ask ourselves what role depreciation plays during the valuation process. Okay. Depreciation again is basically the decline in value of a particular item. Correct? So here in a building, we talk about 2 aspects. We talk about the economic life of a building. Basically, it is the time span for which a building is a profit making entity. Understood? So a building makes a profit when the amount that it is able to make from the building, when the amount that a person is able to make from the building, let us say X as a certain sum of money, that is always positive. Okay. So let us say I'm getting the gross income from a building can be termed as Y over here. Okay. So if let us say I have a gross income of Y, and let us say my expenses are termed as S. Okay. So my final the profit that I make from the building is equal to X, which is Y minus S. And that figure X has to be in the positive. Okay. So where your expenses are greater than your income, it automatically stops being a profit making entity. And that basically means that the economic life of the building has been completely destroyed. Okay. So if we were to consider it over here, the economic life can be this kind of a bubble over here. Then you have something which is known as the physical life of the building. Okay. So the physical life of the building is the total life of the structure, including the economic life. So it is not necessary for a building to be economically viable for the entire time period of its existence. Okay. So this can be considered as the physical life of the building, and the economic life of the building is considered as a small part of it. Okay. So a depreciation basically means a decline in value or becoming less worth. Okay. So here what happens is that because over a period of time, the there is wear and tear, there's natural wear and tear, there are problems which a building faces. The economic value and the physical value, the economic life and the physical life of the building reduces in this manner. So what we see as the dotted lines can be considered as the reduced economic and the reduced physical life of the building. Okay. Then we ask, how does depreciation happen? So we have wear and tear as a result of constant use. So again, if we take human examples over here, wear and tear, the first thing that we experience as wear and tear in our bodies is our joints, right? So arthritis can be considered as the single most common cause of wear and tear, right? Physical deterioration and decay due to age and exposure. So depending on the kinds of elements and the kind of deterioration that happens due to physical conditions, your entire building may deteriorate and decay. All right. So this is indicative of all the things that can cause some or the other kind of kind of problems for the built structure. Okay. Then obsolescence. Again, obsolescence we've already talked about. So this is basically a simple cartoon over here to try and explain what obsolescence is. So in life, 60 is the new 40, and in the workplace, 40 is the new 60. All right. So the older you become at a workplace, the more obsolete you become. Okay. It's no longer a given guarantee that the more experienced you are, the better your chances at your workplace is going to be. Structural deterioration. So what we consider as a good, strong building over here at the, let's say, if you take the time period in consideration over here, as and how the time goes on, your structure starts to deteriorate. Okay, so in the first 5 years, you generally don't consider too much deterioration. After that, subsequent to that, there will be a very rapid degree of depreciation due to structural deterioration. Okay. So now we move straight into the methods with which we will calculate depreciation. Okay. The first one is the straight line method. So here we assume that depreciation follows a straight line. So if we were to give it a simple idea over here, if I have, let's say, a straight line of time here, depreciation can be considered as a straight line, a straight declining line, as in how the building age advances. Correct? So it's a uniform depreciation rate which is adopted through the life of the structure. Okay. And when we are considering depreciation rate over here, we always assume that 10% of the replacement cost is assumed as salvage value. So a replacement cost is basically the amount of money which would take to replace a structure to where it was at the time of its commencement. So let's say I have a building over here which is um, around a building which cost me around 15 lakhs to construct. Okay, so the replacement value will be the exact same uh, 15 lakhs. Okay, irrespective of what period of time you decide to construct it. So let us say I constructed a building 10 years ago for 15 lakhs. Okay, owing to economic changes, owing to inflation, so on and so forth, what happens is that the actual construction cost would have become almost double of it. Okay, but when we are considering replacement cost, we consider the amount it took to actually replace the building, takes to replace the building. So let's say in 2010 I paid 15 lakhs for the purpose of constructing a building. In the year 2020, it can be assumed that the same construction will take 30 lakhs. All right. So if I demolish this structure and try to construct it in the year 2020, I will pay 30 lakhs for it. But as a standard of calculating, doing valuation or calculating depreciation, replacement value remains as 15 lakhs. Understood? So if we are calculating depreciation over here, what we do is we look at the factor D over here. All right. So in terms of D over here, we put the age of the building. Okay. And we divide it by the life of the building, assumed life of the building. And we consider the replacement cost. Okay. The replacement cost is basically the amount that we talked about as the actual value minus 10% for salvage value. Okay, so that is your factor over here, 0.9. Okay, so here is this standard tabular column where we try to understand what the life of buildings can be estimated as. Okay, so there is a rate of depreciation over here which is calculated, but again, that is dependent on the age of the building over here. Correct? So if it is a monumental building, you consider around 100 years. If you consider RCC frame, it is 75, load bearing 55, semi-permanent 30. So on and so. These are the methods in which we try to calculate the life of the building. Okay. So this rate of depreciation per annum can be considered as the amount that it is going to depreciate for a building which is actually the same age as the life of the building. Okay. Clear so far? This may be actually confusing even when we try to deal with it in class. So I have to ask you this question when we are dealing with it online. Okay. Shall we move on?
Yes, sir.
Okay. So the second method of calculating depreciation is by using the sinking fund method. All right. So the owner of a particular property, he sets aside a small sum every year during the life of the building, and he considers a period of 1 year, assumes a period of 1 year for rebuilding, and there will be a certain amount of income which is lost during that particular building period. All right. So this sinking fund basically is a small little investment which you keep aside for the purpose of covering you when you have that period where you're rebuilding and you're going to lose an income. Okay. Sinking fund contributions are invested always in risk free securities. Okay. And the sinking fund, the risk free securities comprise of two components. So you have an annual deposit and you have compound interest. Okay. Now, to give you a simple understanding of this, think of it as something which is known as a recurring deposit. Those of you familiar with those of you who have been brought up in brought up with some understanding of banking will be able to directly relate with this. A recurring deposit is basically a deposit which you repeat over a particular period of time. Correct. So, in the case of recurring deposits of banks, you do it over a particular month, set of months. In the case of the sinking fund over here, it is an annual deposit. Okay, so you have exactly X amount of money which you repeat over a prolonged period of how many ever years until the point where you say that you're going to reconstruct the entire building. Okay, so that can be considered as your sinking fund. So the sinking fund with accrued compound interest should be sufficient to meet 90% of the replacement cost, plus the income which is lost during the period of rebuilding. So you have something which is known as an annual sinking fund factor. So you guys can make a quick note of this formula if you wish, or this presentation will anyways be uploaded, so you can definitely correlate with that. And the annual sinking fund factor is basically this one, R by 1 plus R in to the power of n minus 1, where R is the rate of interest which is considered as a part of which is this one, this compound interest aspect. N is the time period of the sinking fund. So how many ever years you are going to put money into this sinking fund, that is considered as the time period over here. Okay. So if we were to calculate it, the annual sinking fund is equal to this factor ASF into the cost of replacement minus salvage value minus plus the income which is lost during rebuilding. Okay, there will be a problem which will be given at the end of this exercise, which you guys can use to try and solve this, where you can use these formulas to solve this problem. Okay. Then we look at the reducing balance method. Here we assume that the depreciation does not follow a straight line path. Okay. So the depreciation is considered to be faster in newer constructions than in older constructions. which is a logical assumption. The way our more modern constructions are done are such that it can be easily demolished and it can be replaced. So the idea that depreciation is faster in new constructions is almost logical. Okay. And here depreciation is assumed at a fixed percentage on the written down value of the structure. Okay. A quantity survey method. Again, this is where we talk about the valuation in a much more detailed manner. So you talk about studying the property in detail. You understand the loss of value due to life, wear, tear, decay, etc. And each steps requires some logical assumption without any fixed percentage of the cost of property. Okay. So the idea of quantity survey is basically to say that not every part of a building will depreciate at the same rate. Okay. So let us say if you were to take a construction which is around 20 years old, if I'm trying to value it, I'm not going to assume that my building itself is going to depreciate at the same rate as possibly some of the other elements of it. For example, in a 20-year-old building, it is easy for us to assume that the building itself, the shell of the building itself, is going to deteriorate at a slower pace because the quality of construction was different at that point of time. Okay. However, we cannot say the same for parts of the building which are exposed to the elements. So if there are steel elements which are exposed to the if there are steel parts of the building which are exposed to the outside, it is going to deteriorate quicker because there is going to be rust, there is going to be constant rain, sunshine, sleet, snow, so on, whatever. And it is obviously going to deteriorate faster than the building itself, right? A similar assumption can be done for wood, which is used for the purpose of your windows. Okay, wood deteriorates much quicker than most of the other elements of the building. Okay, so if let's say you have to replace a door or a window, that is going to happen much quicker than any other replacement in terms of your civil construction. In a similar manner, your tiling, your paint, your plaster, all of these things can be considered as separate quantities, entities which have separate quantities. And based upon that quantity survey, you will be calculating the depreciation of the entire structure. Okay. I hope that is clear so far. So, anyways, we will move on. We will close this session for today. So, the first thing is the key terms that we set aside for the self study. So, basically, this is going to be a simple question and answer session. Understood? You're going to differentiate between the various methods of calculating depreciation because we've defined it over here, but you have to differentiate it. Find points of differentiation between each type of calculating depreciation. Sorry, yeah, depreciation. You have to differentiate between the economic life of the building and the physical life of the building. Again, this should be fairly easy for you because you guys have sat through the economics module in the 5th semester, because we've talked about what the physical life of the building can be and what is the economic life. All right. Then you will also explain how these two parameters affect the valuation of buildings. Okay, we have a simple problem over here. You have an old building which has a replacement cost of 30 lakhs, excluding the cost of land. You're given a rate of interest. You're giving 20 years over here as the future life. So, as a part of this problem, the sinking fund is calculated for 20 years. All right. And scrap value we have already agreed upon as 10% of the cost of purchase. All right. So if you guys have difficulty in solving this problem, please get in touch with Dominic sir or I, and we will be able to clarify your doubts. Okay. Perhaps you guys can let go of the last question over there. The first four questions are more than sufficient. Okay. The last question is not entirely relevant over here. So the first four questions will be more than sufficient for you to complete this assignment. Okay. All right then. So we will call an end to today's session. The recording of this session should be hopefully complete, and it will be uploaded a little later. All right. So those of you who are yet to submit the first assignment, please, I urge you to do so that we can finish the evaluation and set it aside. Okay.
Yes, sir.
Okay.
Thank you, sir, for another interesting session. I think hope the students are catching up and submitting the assignments on time.
Hope so, sir. Yeah. All right then. We will call an end to today's session. Thank you all for coming.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Cheerio.